Hello everyone, myself Kiran Kadakuntla, lecturer, Department of Electronics and Communication Engineering. Today we are dealing with the session 2, that is rectifiers. Okay. So we are in the session 2 of unit 1, that is power supplies. In the previous session we have discussed about the regulated power supply. In that we have discussed what is the need for regulated power supply, and we have understood what are the factors influencing or affecting the functionalities of unregulated power supply. Even we understood what is the difference between regulated and unregulated power supply. After that, we have discussed the block diagram of DC regulated power supply. So what are the blocks it has? We must remember the block diagram of a DC regulated power supply so that we will understand the complete operation of the power supplies. Okay. So in the block diagram, we understood that the input will be taken from the AC mains, that is a 230 volt AC. Then we will convert that voltage into lower voltage by using the step down transformer. So step down transformer converts the higher voltage to the lower voltage, but the output of the transformer will be AC only. But we want DC. We use rectifier to convert the AC to DC. But even the output of the rectifier is not smooth DC, it will be having the pulsating, or it will have a ripples. To smoothen the waveform, we pass this to the smoothing circuit or filter circuit. The filter circuit operation is to smoothen the waveforms, and it will provide the output. But its output is not constant, even it has some fluctuations. Many of our electronic instrument expects the constant voltage. Okay, its performance will be affected if there is any variation in the supply voltage. Okay, to have the constant output voltage, we use a regulator. After that, after the regulator, this will be provided to the load. Okay, so this is what we discussed in the previous class. Now in this session, we are going to mainly focus on the rectifier present in the DC regulated power supply. We have seen the second stage in the power supply is rectifiers after the step down transformer. We understood that it converts the AC to DC. In this session, we are going to understand what is the statement of rectifiers, what are the types of rectifiers, and we are going to understand completely what are the types and how they work. Okay, so let's begin with the session 2, that is rectifiers. Okay, in this session, these are the topics we are going to cover. First, we are going to learn the definition of rectifier. Okay, then parameters of rectifiers. Then we'll understand types of rectifiers. And in this session, we'll be dealing with the half wave rectifier, then its circuit diagram and working. Okay, so these are the points we'll be covering in this today's session. Okay, so first we'll understand the parameter of rectifiers. Even we discussed these factors earlier. Okay, so ripple factor. So what is mean by ripple factor? Okay, so ripple factor means we know that the output of the rectifier is a DC, but it has some ripples. Okay, so that means even the output is DC, it has some AC content, means it has some variations. So that factor is called as a ripple factor. So how we will denote this? It is a RMS value of AC component present in DC output to the average value of a DC output. So in this we are using the word like RMS value and average value. We already understood this. In a AC content, we will be having the different values like peak value, RMS value, average value. Okay, just we'll revise the little bit regarding these values so that you will be comfortable to understand the statements. So what is mean by peak value? In a sine, we know that the waves will be increasing and decreasing. Okay, the highest value will be taken as a peak value or maximum value. And also we have a RMS value. What is meant by RMS value? Actually, it is a ability of the heating the elements. Okay, example, if the DC content or DC value is heating element of certain temperature, the same equivalent AC value will be considered as a RMS value. RMS means root mean square value. Similarly, average value means it is about the transferring the charge. It means the DC transfers certain charge. To transfer the same charge, what is the amount of AC required? That AC value will be taken as a average value. So we already discussed this in our first semester BCCC subject. So you go back to that topic and we can revise the things. Okay. So in this, ripple factor is RMS value of a AC component present in a DC output. DC output is present in the output of the rectifier. Okay. Then this is the ripple factor statement. Then one more parameter is the rectifier efficiency. So first we'll discuss what is meant by efficiency. We already know what is meant by efficiency. It is the output power to the input power. It is a ratio of output to the input. Here the rectifier efficiency. So what is the output of a rectifier? It's a DC. What is the input of a rectifier? It's a AC. Okay. So let's see the statement. Rectifier efficiency will be denoting with the eta. Okay. And our ripple factor will be denoting by the gamma. Okay. So rectifier efficiency eta is equal to DC power delivered to the load. Just you can recall the block diagram of that power supply. In that also we have seen that the output of the rectifier is passed through the many section, then it reaches to the load. So DC power, output power is DC power to the AC input power from the transformer secondary. So what is the from where we'll get the input to the rectifier? From the secondary of the transformer. This will be the input for the rectifier. So in writing the equation, PDC means DC power divided by the AC power, because output is a DC and input is a AC. So this is the equation for the rectifier efficiency. Let's see one more, few more parameters. One more is a peak inverse voltage. Peak inverse voltage means it is a maximum reverse voltage that can withstand by the diode. We know that the diode will be operating in the forward bias and reverse bias. Okay, so during the forward bias it will conduct and it will pass the signal, but when it is connected in the reverse bias it blocks. Okay, that we know. Here maximum all the diodes will be having its own capability. Beyond that, if you apply the reverse voltage, it will break down or it will damage. Okay, so PI will describes what is the maximum reverse voltage that can withstand. Okay, and it unit will be volts. Then ripple frequency. Ripple frequency means we know that output of the rectifier is having the ripples. Okay, and we'll be calculating the frequency of that ripples. Okay, so this is a ripple frequency and that is denoted by F naught. Okay, so these are the parameters of rectifiers. So now we are dealing with the expression for ripple factor. Okay, so the symbol is gamma. For typing purpose we written as R, but actually it is a gamma. Okay, so we already understood what is ripple factor. We'll see the derivation for that. So how it can calculate? We know that gamma is equal to RMS value of AC component to the DC value of a DC value component. Okay, that is denoted by VR RMS divided by VDC. Okay, RMS means root mean square value, VR means ripple voltage. Okay, then RMS equation can be written as square root of V square RMS minus V square DC. Okay, similarly RMS value for ripple current IR RMS. RMS means root mean square, R means it's a ripple. Ripple current of RMS value is given as square root of I square RMS minus I square DC. Okay, so we need to remember these two equations. Now if we substitute these two values, here it is VDC, VRMS is this square root of V square RMS minus V square DC. If you simplify this, you will get the equation gamma is equal to square root of VRMS divided by VDC whole square minus 1. So this is the equation for ripple factor. So you must understand how we got this and you must remember this equation to solve many problems based on the ripple factor. Okay, so just go through it, very easy to understand. Just we have to remember this statement, this equation, and this is the statement of the ripple factor. Similarly, now we are going to understand expression for efficiency. Okay, so we already understood what is meant by efficiency. It is a ratio of output power to the input power. And in a rectifier, what is output? DC. And what is the input? It's a AC. Okay, let's go through its expressions. So it is a eta, that's efficiency is given as DC output power to the AC input power. Output power DC is given as PDC. Input power AC is written as PAC. Okay, so this is the equation for efficiency. Now we are going to understand what is the PDC and PAC in the circuit. DC power delivered to the load resistance RL is given by. So now we will be taking the value of PDC, power in the output of rectifier. So power can be calculated using the current and resistance. Okay. So current DC output current will be IDC, and the resistance will be load resistance RL. So what is the power equation? It's a I square into R. Okay. As per our Ohm's law, we know that power is equal to I square into R. Here I square is I square DC and R is a RL. So this is the equation for the PDC. Okay. Similarly, AC power input from the transformer. Okay. So now that power here also we are taking the I square into R. We are dealing with the AC, so we will take a RMS value. PS is equal to RMS value of a current, that is I square RMS, into we need to take the resistance. Now just understand that when you are dealing with the input power, it has to pass through the diode and the load. Okay, so it will experience the two resistances connected in series. One is a load, one more is the forward resistance of the diode, because we are using the diode for the rectification purpose. That has its own internal resistance, that is denoted by RF. Okay, so for AC power input, these are the two resistances comes in series. So R will be written as RF plus RL. But here you can see it, we are dealing with the DC output power, so we have taken only RL. We are not going to take this RF because the DC is only output of the rectifier. So we have the PDC and PAC. We can substitute in this equation. Before that, we need to understand one more thing. Here we have a two resistors RF and RL, but actually RF is very much less than RL, because the load resistance which will be having higher value. This is the forward resistance of the forward biased resistance of the diode, which is very less. So what we can do, you can just neglect the RF value. Then this PS equation will be I square RMS into RL. So just substitute this PAC and PDC value into the this efficiency equation. So PDC by PAC, PDC is given as I square DC into RL, and PAC is given as I square RMS into RL. So here RL get cancels. So this we can write it as in the bracket IDC divided by RMS whole square. So this is the expression for efficiency. So just go through once how we can obtain the equation for efficiency, and even you have to remember the efficiency equation, so that it's very helpful for you to solve the problems. So we understood the parameters of rectifiers. Okay, then we have discussed about the expression of ripple factor and expression of the efficiency. Okay, so now we start discussing about the rectifiers and its types. So first we'll understand what is rectifier. Even when we were discussing about the block diagram of power supply, then also we discussed what is meant by rectifier in simple. Okay, in brief. Okay, we'll completely understand here. So first we'll understand what is meant by rectifier. So we already, as we already discussed, the rectifier is a device or circuit which converts AC input supply voltage into DC output voltage. Okay, and this process is called as rectification. So we discussed that it converts your AC to DC, alternating current to direct current, and this process we call it as a rectification. Even you may ask this question, what is meant by rectification? Then you need to answer this. Then the rectifier output is pulsating DC containing the AC component in it called ripples. So in the previous block diagram also we have seen that the rectifier output is not completely smooth. It has its pulsating DC and it has AC component. That AC component we call it as a ripples. So we have seen that ripples in the output of the rectifier. Okay. So this is the rectifier. Now half wave type of rectifiers. So what are the types of rectifiers? So mainly we have two types of rectifier. One is half wave rectifier, one is a full wave rectifier. So half wave rectifier means where it will be operating only for the half of the input signal. Full wave means it will be operating full wave of the input signal. Okay. So these are the main two types. And in full wave rectifier, once again we will be classified into two types. One is a center tap full wave rectifier, and other one is a bridge type full wave rectifier. Okay. So in these two, the difference is the element used. The output will be full wave, means the output of the rectifier will be present for the full wave of the input signal, But in the center tapped full wave rectifier, we'll be using the center tapped transformer, and in bridge type full wave rectifier, it will be using the diodes in the form of bridge. So even we'll discuss these things in detail. Okay, so let's discuss one by one. In this, first we are going to discuss about half wave rectifier. So now we'll deal what is half wave rectifier. Okay. So first you understand half wave rectifier means it will be using only one diode. Okay, only one PN junction diode, and it will be operating for only half wave of the input signal. Okay. Okay, let's go with the statements. Half wave rectifier is a circuit that converts AC input voltage into DC output voltage. Okay, it's as per our rectifier statement. Then it is a type of rectifier circuit that allows only one half cycle of an input AC voltage and blocking the other half cycle. So in this, it will operate or it will passes only one half and it will block the other half. That is why it is named as half wave rectifier. Okay, it's not full wave because it's not passing the full wave to the output. And next point regarding this is it uses only one semiconductor PN junction diode which conducts current only in one direction. Means how many diodes it will be having? Only one. So you must remember this. It's important. It having only one diode and it conducts current in only one direction. So we know that when we have only one diode, it will be passing with only one direction. So the opposite direction it will be in a reverse bias and it will blocks it. So only one direction is possible. Okay, and one more thing we must remember, what is its efficiency. Okay, so it conducts only for half cycle of the input signal. Its efficiency will be 40.6%. So you have only 50% you are passing at the output side, then it will be filtered out and other processes it will pass through. So you can expect less than 50%. So it will be 40.6. You in next sessions you will be dealing with how we can get this 40.6 percentage of efficiency, and ripple factor will be 1.21. So you can observe here the amount of ripple is high. Okay, so because it has only a half cycle present at the output side, the ripple will be high and it is 1.21. So these are the points to remember regarding the half wave rectifier. Okay, so try to remember these points. Then we move to the operation of half wave rectifier. What is the operation, how it performs, how it operates, and what will be the output and all. Okay, just go through these points. Okay, so if you understood the meaning of half wave rectifier, let's move on to its operation. So this is the circuit diagram. This is circuit diagram of a half wave rectifier, and this is the its waveform. Okay, so as we know, it will be taking the input from the AC mains voltage. So can we directly convert into DC? No, because it will be having the higher voltages and we need only lower voltage at the output side. So we cannot use it directly. So we have to reduce the voltage, okay, or decrease the voltage. How we can do it? By using the step down transformer. So we are using the step down transformer. Okay, so this is the primary of the transformer and this is the secondary of the transformer, and we have one diode connected to the output of the transformer or the secondary of the transformer. So this point we can denote it as S1 and this point we can denote it as S2. Okay, it helps us to understand the operation. When we are discussing about the operation, this point can be denoted as S1 and this point can be denoted as S2. And this is the diode connected in this form, okay, as you can see in the circuit diagram. Then output of the diode is connected to the load and this is the output VDC. Okay, so in the waveform part, this is the input where we have a complete cycle, and at the output side you can observe only half cycle is present. So during this positive half we are getting the output, and during the negative half we don't have any output at the output side. So it has only half wave at the output side. Okay, So this is the circuit diagram and waveforms of half wave. Let's discuss about the operation. So during the positive half, okay, so AC has a both positive and negative. During the positive half, the switch S1, sorry, the point S1 will be positive and point S2 will be negative. Okay, when this is positive, that is connected to the anode of the diode, and this negative is connected to the cathode of the diode. Then what will be the, in which condition it will be? Is it forward bias or reverse bias? It will be forward bias. We know that whenever a positive is connected to the anode and negative is connected to the cathode, diode operates in a forward bias. Whenever it is in forward bias, it will conduct and passes the signal. Okay, it's like a closed switch. So during the positive half cycle, it is forward biased and it conducts, is act like a closed path. So this signal passes to the load and the output. So what happens? So whatever the output of the second output of the transformer, that will be available at the uh, load, available to the load. You can observe here. The output will be same as input during this positive half cycle. Okay, understood this part? This is the positive half cycle operation in the half wave rectifier. Okay, let's discuss about the negative half cycle. Now see, during the negative half cycle, so S2 will be positive and S1 will be negative. Okay, because it's a negative part, negative half cycle. So earlier it was positive and it was negative. Now it is reverse. S2 is positive and S1 is negative. Let's see what happens to the diode, means how it works. Okay, in which bias it will be. So it is negative. Negative is connected to the anode and positive is connected to the cathode. So it will be operating in a reverse bias. So whenever it is in reverse bias, it will not conduct and it acts like a open switch, or you can say it will block the signal or the values to passing through it. So during the negative half cycle, it acts as open switch and it not allows any signal to pass through it. So output remains zero. So you can observe in the waveform, during the negative half cycle of the input signal, the output is zero. Okay. So once again, next positive half cycle, it comes in forward bias and it will conduct and the output will be same as your input. Once again, during the negative half cycle, it comes in reverse bias and act as open switch and it will not pass. So it will continues. So what happens in for complete one cycle of input signal, we have only one pulse or only one value, that is a positive value. So, or only half wave is present. This is why it is called as a half wave rectifier. Okay. So you can see here we have only 50% of the output. Other 50% is blocked. So efficiency will be less than 50%. As we have seen, it is 40.6. Okay. So 40.6% is the efficiency of the half wave rectifier. So this is the operation of half wave rectifier. Let's go through this, understand this. If there is any doubt, you can go through it again. Okay. Then we'll move on to the its question answer session. I hope you understood the concept of operation of half wave rectifier. So now we'll discuss about the multiple choice questions. Okay. So in multiple choice, these are the questions based on the concept of the what are the topics we have discussed till now. Okay. Let's I read the question and I will go with options. Then I'll give some time to think, try to answer on your own. Okay. If you're not able to get the answer, then I will answer it. Okay. Let's go with the first question. Half wave. First question is half wave rectifier circuit makes use of dash. Means let's see the option: one diode, two diode, three diode, and four diodes. So it is asking how many diodes it will be using. So we already discussed it, and even you have seen the structure or circuit diagram of a half wave rectifier. It's very easy to answer. So can you answer what is the, which one is the correct option? Good. I hope many of you got the correct answer. That is a one diode. So we have seen the circuit diagram. Just go back to it. So you can see this. How many diodes we have? Only one diode. So which one is the correct option? Option A is a correct answer for this question. Okay. So let's see the next question. Second question is half wave rectifier conducts for? So it is asking regarding when it will conduct. Okay, let's go with the options. First one, only positive half cycle and blocks the negative half cycle. Second option, both positive and negative half cycles. Third option, either one or both cycles of the AC input. And the fourth option is the all of the above. So which one is the correct answer? So have you got the answer for this question? Fine. I hope many of you might already got the answer. Let's see with all the options. Let's start with the B. Okay, we'll come back to A after that. So it says that both positive and negative half cycle it will conduct. Is it true? No, we have seen the operation during the positive it was conducting, but during the negative it was not conducting. That means this option is not a correct answer. It's a wrong answer. Next is the one more option, that is either one or both cycles of a AC input it will conduct. So it was operating for one, but is it operating for both the cycles? No. Okay, because it's a half wave rectifier, it operates only for the one half cycle. It's not operated for both the cycles, so this is not the correct answer. When B and C are not correct answer, you cannot go for the all of the above. Okay, so let's see the first one whether it suits the answer. Only positive half cycle means it conducts only positive half cycle and blocks the negative half cycle. So is it correct? Yes, it's correct, because during the positive half cycle the diode was coming into the forward bias and it was conducting. During the negative half cycle it is going into the reverse bias and it was blocking the signal. Okay, so the correct answer for this question is option A. That is a only positive half cycle and blocks the negative half cycle. Okay, let's see the question number 3. The efficiency of rectifier circuit is defined as the ratio of. Okay, so it's dealing with the efficiency of a rectifier. Let's see the options. DC output, first option, DC output power to AC input power of a secondary of a transformer. Second option, AC input power to AC output power of a secondary of a transformer. Third option, AC input power to DC output power of a secondary of transformer. The fourth option, all of the above. So think which is the correct. So I told you what is the efficiency means. Efficiency means it's the output power to the input power, and here we are dealing with the rectifier efficiency. So you must remember what is the output of a rectifier and what is the input for the rectifier. Then you can easily answer this question. So here let's go with the answers. Once again here also, first one is DC output power to the AC input power of a secondary of transformer. So we know that the efficiency of rectifier means efficiency means output power by input power. So it's also saying output power to the input power, and output is DC power and input is AC power. It seems like correct. Okay, let's see the other answer. So second option is DC input power to the AC output power. Is it correct? No. Is it the ratio of input to output power? No. We know that efficiency means it's the output power to the input power, and it is in reverse. So it is not a correct answer. Next, third one, AC input power to the DC output power. Once again, here it is giving the ratio of input to output, which is not correct. We know that efficiency means it's a output power to the input power. So these two are the wrong answers. Then all of the above is also wrong option. So which one is the correct? Option A. Option A says that DC output power to the AC input power of a secondary of transformer. So correct option for question 3 is option A. Okay. Let's see the next question. The ratio of RMS value of AC component to the average value of DC output is known as. So option given is efficiency, PIV, ripple factor, none of the above. So which one is the correct answer? So in this session, we have discussed about these all the factors or all the parameters. So if you remember all the parameters also, you can answer it. Or if you know the direct answer for this question also, you can answer. So let's go in reverse way. Means first we'll understand each concept, then whether it suits to this question. It's dealing with the ratio of RMS value of AC component to the average value of a DC component. So first option is efficiency. Is it true? No, because we know that efficiency deals with output power and input power, and the question is not related to that. So this is also wrong answer. Then PIV, peak inverse voltage. We know that peak inverse voltage means it is the maximum reverse voltage that diode can withstand. But here the question is not dealing with that concept. So this is also a not correct answer. So ripple factor. We know that ripple factor means it deals with the amount of ripple presence in the rectifier output. So even in the question also dealing with the same. It's dealing with the AC component, that is the RMS value to the average value of a DC output. So it suits for this ripple factor. So this seems to be a correct answer. The last option is none of the above. Since it is correct for the ripple factor, the option for question number 4 is a C, ripple factor. Okay. So last question for this session. Okay. We'll go with the question. The ripple factor for half wave rectifier is 0.48, 4.8, 21.1. The last option is 1.21. Even in this session, we have understood what is the value of ripple factor of a half wave rectifier. In the succeeding sessions, we'll be going with the derivations, how we can get that value. So which one is the correct answer? So correct answer is 1.21. This is the ripple factor of a half wave rectifier. The answer for question number 5 is option D. So this is the answer for this question. Okay. So I hope you understood the today's session. Okay. So let's revise what are the things we have discussed today. So first we understood what is meant by rectifier. So parameters of rectifiers. Okay. Parameters like ripple factor, efficiency, PIV, okay, and other things. Then we understood the expression for ripple factor and efficiency. Then we understood what is meant by half wave rectifier, operation of half wave rectifier, and output or waveform for the half wave rectifier. So this is regarding the session 2. Thank you and all.